Hello friends, welcome back to my channel. Microsoft released a new model named as LLaVA-Med a few days ago. What caught my attention in this model is this is one of the very few models that I know of which were trained in histology and pathology images. Earlier, whatever models I have seen or worked with were using the X-ray or MRI or CT scan images. Being a pathologist, I wanted to test it out, but when I read the installation instructions, I realized that it is not easy as it seems, and there were multiple issues with the repo installing it in Google Colab. So today in this tutorial, we will see how to properly run it and test it in a Google Colab. Please note that due to requirement of high RAM, this requires a paid account of Google Colab. In the free account of Google Colab, it won't run. I'm using Google Colab Pro Plus account to test it out. Before jumping onto Google Colab, let me show you the changes that are required inside the repository. So I forked this repo and made some changes. You can see that there are changes in the Gradio web server. Without these changes, I was getting issues. You can try out directly from the original LLaVA-Med repo released by Microsoft and see the changes, see the errors yourself and decide accordingly. But for me, these changes made it possible to run on Google Colab. So I increased the timeout from 10 to 5,000. Apart from that, there are certain changes in the function of build demo. Mostly there were some entities whose visibility were set to false. I changed them to true. So in the line number 326, similarly in 359, the only changes I did was I made certain visibility to true. So this is the only change that I did in this repository. Now coming to Google Colab. So to use it on Google Colab, as I mentioned earlier also, we need a paid account. I'm using A100 along with high RAM. So let us first connect with the GPU. So I will connect with my Google Drive also. So as you can see, I got A100 along with somewhere around 83.5 GB of RAM. So let us first clone the repo. As I mentioned, I made some changes in the repository, so that's why I'm cloning it from my forked repo. As mentioned in the installation instruction, after cloning the repo, we just need to install some packages. Since we are using it in Google Colab, right now we don't need to create a new environment using Conda. So I will just run these commands. Basically, it will uninstall the pre-installed Torch and CUDA versions, and it will install the required versions which are specified by the Microsoft, that CUDA 117 and Torch Vision 0.15 along with Torch 2.0 is required for this to work. So let us wait for the installation to finish. Meanwhile, let me cover the next steps, because these are the steps where certain changes have been made. So as you can see, once we finish the installation process, after that, if we go to the model download page, we realize that these are not the final models. These are just the delta weights. To make it usable models, we first need to convert these using original llama weights. So when our installation finishes, we first need to download the checkpoints. After that, we need the llama weights. To get the original llama weights, as mentioned here also in the Hugging Face repository, that we need to fill this form. This is the requisition form from Meta. Once you fill this form, you get access to it from the Meta. And when you get access to the original llama weights, again, those are not usable because we need to convert these weights into Hugging Face transformer format. So once you get access to the original llama weights, you can upload it on Google Drive. I have uploaded it here. I will unzip it in the temporary space. And after that, as mentioned here, we need to convert it into Hugging Face transformer format using this script. Since the file mentioned in this repository has now been changed, so directly running it will throw some error. That's why I have made certain changes here. I will pause the video here so that for the next steps, I can directly demonstrate when I am running those. So the installation is now complete. Let us move to the next step. As I mentioned, these are just delta weights. We can download any of the delta weight that we need. For this demonstration, I'm using the original LLaVA-Med model only, the delta weight of LLaVA-Med. You can use patch VQA fine-tuned or VQA radiology fine-tuned or the sleek one, whichever you want. So I will download it. Before that, let me confirm if I'm in the home directory. Once the download finishes, we will unzip it. Let us wait for these steps to complete. So the LLaVA-Med delta weights have been downloaded. I got an error after in the next command because I forgot to put one exclamatory mark. So right now it is unzipping. So unzipping of the LLaVA-Med delta weights has been finished. Next step is to load the llama weights that we got from Meta. Let us unzip those also in the content directory. So once we have loaded the llama weights into our content directory, it's time to convert these weights into Hugging Face transformer format. So for this, we require another library that is Ascended. So we will first install it. After that, we also need to clone the GitHub repo of transformers because otherwise, if we directly copy this for Python file to convert, it won't work. We need to switch back to previous version that was mentioned on the README file. So we will give checkout to that version. After that, if we run the conversion script as mentioned here, we need to give the input directory path, the model size, and the output directory. So I have set the input directory of llama. The model is 7 billion and the output directory to hf underscore llama underscore 7b that will be created once this script runs. So as you can see, these are the original llama weights. I have loaded only the 7 billion ones. Once it fetches all the parameters and starts converting, so it will create a new folder that is named as hf underscore llama underscore 7 billion. Right now, the temporary files have been created. Once this script finishes, we will get the Hugging Face transformers for format llama weights. So once the llama weights has been converted into Hugging Face transformer format, we now get this folder and all the weight files are here. The next step is to create model from these delta weights and llama weights. For that, I will create those weights inside my LLaVA-Med repo that I initially cloned. So I will navigate to it. And after that, as also mentioned in the instruction file, that to create the weights, we need to run lava model apply delta. And here we need to provide three things. One is base, another one is target, and the third one is delta. So in the base, we need to provide the llama 7b weights. In the target, we provide the output directory, and in the delta, we provide the location to delta weights. So I have provided it here in the base. I have provided the link to the directory where we just now converted the weights, that is hf underscore llama underscore 7b. We will generate the output in lava dash mat dash 7 billion, and this is the location of delta weights. So let us run this command. So let us run it. It will again take some time. So I will pause the video. So once this step is finished, we can see that our model has been created and it is stored in this folder. Now we will use this model for our testing purpose. As can be read in the next step, that to test it out, we need to launch a controller. Also, we need to launch a model worker. And lastly, we need to use the Gradio web server. So all of these commands should run in the background to run it successfully. We shouldn't stop them. So either we can use the terminal and we can run the command and put it in the background. But instead, what I'm trying to do is I'm installing another library that is Colab X terminal. it gives us a little bit advantage over the inbuilt terminal that I can run the command in the foreground and I can monitor it easily. So this has installed properly. Let me zoom it a little bit so the next few lines you can easily read it. So next step is to run the terminal, and in this terminal we will launch the controller. So to run it, we just need to type extern, and as we can see, the terminal is running inside the Google Colab, and we are in the folder in which we should be. And to run the controller, as mentioned here, we just need to run the command lava controller. So I will copy this command and paste it. We should wait till we get UVCon successful, this command, this line, UVCon running on. So here we are getting some error that while attempting to bind the address, it found out that it is already in use. Sometimes we get this type of error, maybe because we are using X terminal, maybe due to some other reason. So we will just change the port number. But if we change the port number, we should make sure to use the new port number in the next few lines also. So I will make the necessary changes also. So let me show you the command again. So instead of port 10,000, I will use 10,001. And I rerun the command. As you can see, we are getting UVCon running on this port. So I will let it run only. After that, I will open another terminal. This time I will make the changes for model worker, and my changes would be, first one is I need to change the code. Second one is I need to change the path of my model because by mistake from my earlier work, I copied the path. It is different this time. So I will copy it from here, copy the path, and I will paste it here. Now I will use this whole command and run it in terminal. So let us wait for some time. It is loading the checkpoints. So as we can see in our the earlier terminal as well as this one, that we have got a successfully running model and the model has been loaded. We can also confirm this uh, from here that the model has been loaded inside the GPU RAM. The next step is to test out the model, and this one I don't need to run inside a terminal because we don't need to keep this command running. The only change here I would make is because our port number is changed. So I will change the port number and I will run the command to test message. We can see in the previous logs, this is why I used a terminal, this another library for Google Colab terminal instead of the traditional terminal that is already available there. Because now I can check my logs easily. So I can see that it is getting the proper heartbeat and all that message. I got the reply from the test message. So now I know that my model has been loaded successfully. And here it was the demo message that was created by Microsoft. Next step is to launch the Gradio web server. Remember, initially we made some changes inside the Gradio web server file because I was getting the error. I'm hopeful that after this changes, this time it will run in a single attempt. There are two things that I want you to know. That first one, I changed the port. So I will change the port in this command also. And you can see from the original command, I have added an extra parameter of share so that I can get a public URL to access the Gradio website. So I will run it. Meanwhile, I will check in the previous logs also if it is running successfully. Yes, it is running. And here I have got a local URL. I'm waiting for the public URL. I have got it. So let us open it. It is loading. So what happens if we don't make the changes which I suggested here? The issue I was facing was I was not getting this window where I can select my model. I was not getting this box where I can chat with the model. So that is why I was facing. That is why I created a fork and made some changes. If you are not getting these errors in the original repo, that's very good. So, anyways, our model is running now and the video is live. First, we can test it out on the demo images that are given there only. So let us test this image. So this is a histopathology image. So I will test it out. So as you can see, we are getting that it is understanding this is an histopathological image slide. And apart from that, the important thing, whether it was able to diagnose it properly or describe it properly, no. So that's why personally, being a pathologist, I didn't like it that much because the traditional deep learning models, they are far much better, at least at present, than this one. If we train our model on squamous cell carcinoma or specific malignancies, we get better result in those. So from pathology point of view, I don't even give a good score to this model, but it is a good achievement that we have reached so far within an year. Earlier, we wouldn't even have think about it. So let us move ahead for some radiological testing. So this is then another example. Let us see if it can describe the image. If there is any radiologist watching this video, he can better give the comment whether it has properly diagnosed it. We move to the third one. So this is an image showing mosaicism. So let us see if it is able to identify this plots and describe it. And I'm not using any my custom images or the new images which the model has not yet seen. As you can see, these are the example that are already available on the repository. On this, the model was either trained on or the people who created this model, they have already tested this model on these images. But as we can see, at least in pathological images, the model is not at all good. I have tested it few times before also, in which I found that in radiology it is decent. Like we will see in our next example. Since it is not running, let us see if we are getting any error. So no, the server is running fine so far, but it is taking so much of time. So I think maybe because the maximum output tokens or something has maxed it out. But anyways, what I will do is instead of waiting, what I will do, I will close this radio server and relaunch it. Since we have created it just now, it is not difficult for us to go through all of the steps. We just need to stop the server from this command and rerun it. So because I was getting an error in the Gradio server, I decided to rerun the Colab. I just reconnected it. And since we have already created the model, it is always advisable to save it on your Google Drive. So since I have already taken a backup of my model that was created in the Google, it is in the Google Drive. I don't need to rerun all the steps. So let me also show you how to run it or basically how to rerun it once you have created your model. For that, we just need to run only selected columns. So let us first clone the repo, navigate to, and install the basic libraries which are required. Now we don't need to download the delta weights, we don't need to download the llama weights, and we don't need to convert it. And neither do we need to make the model since we have already made it. This time we will just put the location in our serving from the Google Drive. So I will navigate there. This is the location for the model. I will copy the path and in the model worker, this command I will use inside the terminal. I will put the path. Okay. Apart from this, I don't need to make any other changes. So we just need to wait for the proper torch version and the CUDA version to install. So once this basic installation is complete, we can directly run our controller. Okay, we need to install the Colab terminal again. Time to run the terminal again. Let us see if okay, we will directly use port 10,001 this time. So we got the successful message, Unicorn is running. Now we are in the next step, that is to launch the model worker. So as you know, this time I'm directly loading it from my Google Drive. Please note that this time I'm directly using port 10,001. So it is loading the model. So now as we can see that model has loaded successfully. And if we see that now our resources, that RAM has been decreased. Earlier I checked it that somewhere around 17 GB was 17 GB of RAM was used, and later on now it is using GPU because the whole model is loaded in GPU now. So now we just run a test message. If it is successful, then we can launch the Gradio web server. So it is successful. So next step is to launch the Gradio web server. So this time we will only test it out on radiological sample images that are already shown in the demo page. So the model has been loaded successfully. We'll directly jump onto this question. Basically, in this X-ray, the prompt has been given that if there is an evidence of aortic aneurysm, and we are asking it to choose only from the two options, yes or no. So if we click on submit, we get an answer. Yes, the chest X-ray shows the evidence. But if without this prompt, if I put this image again, and if I click submit, you can see this time it got confused with my earlier prompt. So it is always better to clear the history, and I will again use the same image and I will change the prompt this time, describe the X-ray. So personally, I don't think it is a good description. Any radiologist watching this video can better comment on it. We'll move to the next example. This will be the last one, which is of medical background. I won't be testing the last two. Those are just the basic lava example that are already there, and so many videos are already there for this. So in this prompt, we asked about the abnormality in the right hemidiaphragm, and it's mentioned that soft tissue density mass in the right hemidiaphragm. So because for pathology it failed very badly, I won't be using this in any of my research right now. I would wait for a better model. So the whole purpose for this video was to demonstrate how to use this model, and also if in future if some repo got released which uses the similar kind of step, we get to know how to make model on our phone. Hope you like this video. Please do like, share, and subscribe. That's all. Bye for now.